Hello, hi, good morning, my dear students. Welcome to the chemistry class. In the last class, we have observed that about the continuation of that is gaseous law. So here, I say to you in the states of matter, there are three types of solid, liquid, gases. So gaseous state we have discussed, that is some laws are there, Charles law, Wolff's law, Guidance law. These are laws. Based on that, we have derived the one important equation, that is gas constant law R. Based on that, ideal and non-ideal gases, I hope you can able to differentiate that one. So here main thing is, as I said you people, as here you are going to study the gaseous compound and liquid compounds in this chapter, and solid states you are going to study in the second PUC. The very first chapter is that is. So here, due to this COVID-19 effect, some of the portions they have deleted. Among those concepts, those who have deleted, among that in this chapter, in this states of matter, the next coming liquid state, they have completely reduced that one. Means it is not there in your syllabus. So even though it is not much important, why? Because those they have deleted, they have given some reasons, because you might have studied it in the previous, or you are going to study in the higher. Otherwise, it's not having that much of use in the application by the next higher education. That's why they have removed that one. So main thing here, they have deleted the portion is purely the means completely liquid state. In that liquid state, liquefaction of gas, surface chemistry, viscosity, and some terms are there, but we are not going to use that in the 1 second PUC and degree also, because it's a general explanation. So I would like to clear you the meaning of that one, that's all, because it's not there in your syllabus. No need to write also in your notes. So a liquid state is nothing but here the gases are arranged in a little bit far away. So one condition, and according to the intermolecular attractive force and thermal energy, you can say that here intermolecular attractive force are slightly greater than the thermal energy. If it is predominantly greater, means solid state. If thermal energy is greater, means then we are going to call that as a liquid state. So coming to here, in the liquid state, we are going to discuss liquefaction of gas. So here we can convert the gaseous compound as a liquid by applying some of the pressure. Are you able to understand this concept? So liquid, when we apply the pressure, that liquid molecules are being they are moving in a very far away, means the distance will be more. When we apply the forces, the particles are coming near, so that if the particles are near, the gaseous molecules are converting as a liquid molecules. So it means that how to apply the, means how to convert the liquefaction of gas. Liquefaction is nothing but it's a conversion of gases into the liquid, that is called as liquefaction of gas. So to convert that gas into the liquid, so we are having some conditions. It means that we have to decrease the temperature, because as we increase the temperature, the solid converts liquid, liquid converts gases. To reduce that one, means to convert gas to liquid, we have to reduce the temperature, one thing, and we have to increase the pressure. So this is how much temperature is minimum required to convert the gas into the liquid, that is called as critical temperature. Critical temperature, that is represented as TC. TC is nothing but critical temperature. What is the minimum temperature required to convert, and similarly what is the minimum pressure required? It's the pressure applied at critical temperature is called as critical pressure, and the same volume, the volume which is maintained as a constant, that is called as critical volume, that is represented as capital V and small c, critical volume. These are the some terms. And coming to the main, surface tension is nothing but what here. So you have observed that whenever we are dropping a single drop of water, that water is going to occupy the shape of this one. Means it's going to occupy the shape, isn't it? So water is having a round shaped and down arrow marked water, means the water drop is always not in the form of round. It's not actually in the round, isn't it? It is in the form of this shape. It is in the form of this shape. Why? Because here the force which is acting towards the gravitational force, towards the earth, it's going to pull the energy of the liquid down. Energy of the liquid. That liquid is nothing but water or any of the liquid. For that reason, this force is tending to move towards the gravitational force. The force which is attracted by the gravitational force by the liquid, that energy, that kind of force or effect is called as surface tension. Means whenever a drop of water is falling down, it's in the shape of this one. So why? Because it is due to the effect of surface tension. That effect itself is called as surface tension. And next one is viscosity. So viscosity is what? Look here. Think that here simply I would like to clear you. You just imagine my palm, my hand is surface area, means ground. So if we drop some of the water means those waters are touched to the earth. So above that water, still I put some more waters. So here what happens when the ground level is not uniform, means it is having somewhere downwards, then water will flow. Which one will flow the faster means, can you see here, according to the friction, the upper layers of the water will move faster than the below one. So below one move slightly less, whereas the second one means upper level will be moving fast. Why? Because here this earth is having some surface tension. Because of that, it will not allow the liquid water compounds to move faster, but layer upper than this water will move faster. And if some waters are there above, means upper layer of the water will move faster because it is having lesser frequency. Means friction will be very much less. So as it moves, so here my condition I am telling is, so when the water are having when they are near to the ground level, there is a less transference, means movement of the particles of water is very less. Why? Because it is having the greater attraction, or the frequency will be more, friction, that friction will be more, whereas in the upper layers the movement of the water molecules are fast. Why? Because these are having the lesser friction between the gases. Can you see here? Now it will be easy to show you, because here the water molecules do not have any friction, they will move easily, but the lesser one, it is having the friction, therefore the water molecules, the movement will be faster in the upper layer rather than the lesser layer. So it means that ನೀವೇನಾದರೂ ನದಿ ಕರಿ ನೋಡಿದಾಗ ಅಲ್ಲೇನಾಗುತ್ತೆ ಅಂತಂದರೆ ವಾಟರ್ ಫ್ಲೋ ಆಗುವಾಗ ಅಪ್ಪರ್ ಲೇಯರ್ ಫಾಸ್ಟಾಗಿ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಿರ್ತದೆ, ಲೆಸ್ಸರ್ ಲೇಯರ್ ಅಂದರೆ ಬಿಲೋ ಲೇಯರ್ ಏನಿರ್ತಾವಲ್ಲ ಕೆಳಗಡೆ ಇರೋದು ಫಾಸ್ಟಾಗಿ ಆಗೋದಿಲ್ಲ. ಸೊ ಮೇಲ್ಗಡೆ ಲೇಯರ್ಸ್ ಅಷ್ಟು ಫಾಸ್ಟಾಗಿ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಿರ್ತಾವೆ, ಕೆಳಗಡೆ ಸ್ಲೈಟಾಗಿ ಸ್ಲೋ ಆಗ್ತಿರ್ತಾವೆ. ಸೊ ಮೇಲ್ಗಡೆ ಫಾಸ್ಟ್ ಆಗಿದ್ರೆ ಕೆಳಗಡೆ ಸ್ಲೋ ಆಗ್ತಿರ್ತಾವೆ. So this effect is called as viscosity. It is called as viscosity. Best one example ಹೇಳ್ಬೇಕಂದ್ರೆ, so take a water and put some ink and pour that to the surface, and it will be stay here, and after that you just pour some more water. So the initial blue of the ink water, it will remains here only, but the above that layer whichever you are adding the water, it will move very fast, isn't it? So why? Because this effect is called as viscosity. Viscosity is nothing but upper layer will move faster. So here this is the brief information about the dilated portion. Actually no need to explain this one. I thought that it will help you if you are moving for the competitive level. That's why you should have some meaning of that one. That's why I say don't write, don't read. If you remember means it's well and good for your future. That's all. Coming to the next one, now we are at the end. Hope this will be the last class on this states of matter. I will send you the notes, those not the detailed notes, means whichever I have derived the derivations, you have to practice that one, and some of the theoretical parts whenever it is there, the definition or something. If you feel, you may feel, not all, some of the Kannada medium students, even though some of the English mediums are not even writable, so only for them I am going to send the notes, means I will send in the group. So just refer that one, and don't write only that much. By observing the video, whichever I am writing on the board, you have to note down that one, and try to write that whatever I have given definition at there only. So if I am saying the Charles law, means wherever the Charles law you are written, below that mathematical expression I am not sending, because you have written in the notes by observing the video. So same thing you have to manage that one, and you should be capable to write the answers to the questions properly. So whichever I am sending in the notes, these are not only the theoretical part, the experimental, or I mean the mathematical derivations I have written in the board. So on that day you only write that one. Okay. So coming to the last one, that is we are going to solve some of the problems on the Charles law, Watt's law, and Charles law. So let's begin the first one. The very first problem, that is based on the, I have sent some of the images of PDF just to go through that. In that the very first problem, that is problem number 5.1. 5.1. So here they have given the problem, just observe this one. A balloon is filled with a hydrogen at room temperature, means in the room temperature the balloon is filled by the air. If it will burst, means it will burst if pressure exceeds 0.2 bar, means pressure, if it is greater, means if it is increased more than 0.2 bar, means if its pressure exceeds 0.2 bar, then the balloon is going to be burst, means it's going to be destroyed. So if at 1 bar pressure the gas occupies 2.27 liter of water, means when the pressure is 1 bar, the volume of the balloon is 2.27 liter. Here they have given the question, up to what volume can the balloon be expanded. So here what they have given here, initially they have given some pressure. If we increase this pressure, means increase is nothing but at 0.2 point, if we expand, means the balloon is going to be destroyed, means it's going to be burst. So it means that first you have to remember, at the smaller volume pressure is greater. At the greater volume the pressure will be lesser. You have to remember this one, because it will be confusing as I am explaining. Because can you see at the pressure 0.2 bar, if it exceeds, means the volume of the balloon is going to burst. It means that we are not increasing the pressure, we are going to decrease the pressure. Why? Because so here the pressure is 0.2. We don't know the volume, we have to calculate the volume. Means this will be the highest volume of the balloon. If we expand the balloon, means no doubt the pressure will decreases. Why? Because as the volume increases, pressure decreases. So here they have given, I would like to call this as a P2, and this one is a P1. And P1 means initially at 1 bar pressure the volume remains 2.27. So this means that it is having 1 bar pressure and it is having the volume we have given. Initially at V1, at the volume V1, the pressure is P1. Pressure is reduced here, means that volume is increased. How much volume it can have? If we reduce the pressure again, means if we increase it, it's going to burst. So it means that, look here, I have given the data. So according to the problem, the given data P2 is equal to 0.2 bar. If we extend it, means it's going to burst. So next one is they have given the condition. At the pressure 1 bar, the volume is 2.27 liter. So based on this one, P1, P2, we know, V1 we know, but we need to calculate the V2. At the pressure V2, what will be the V2? This is what they have asked for. So here we are taking the pressure and volume they have given. If the pressure and volume, the relation is nothing but it is according to the Boyle's law. For that reason, we just take this example in means this word in the bracket, means no need to write this one. Just for your convenience, I have written how to determine the formula. So here they have given pressure and volume. It means that it is related to the Boyle's law. So according to Boyle's law, we know that P1 is inversely proportional to the volume. Why? Because their pressure decrease means volume increases. If volume pressure increase means volume decreases, inversely proportional. So P is inversely proportional to B. That's why I can this P1 is equal to P2 V2 according to the Boyle's law. So P1 V1 is equal to P2 V2. But here we are having three terms. We need to calculate the volume. P1 V1 they have given, P2 they have given, means we have to calculate the V2. Therefore, I would like to take the P2 is equal to P1 V1. What about V2 is equal to, I am going to set this V2 to that side. P1 V1 divided by P2. So P1 is nothing but what? It is 1 bar. Volume is nothing but 2.27 divided by P2 is nothing but 0.2. By dividing this one by your calculator, you are going to get the answer as 11.35. 11.35 liter it is. Look here, some of the condition volume they may give in a centimeter cube or dm cube, or they may give you the liter also. So how we have to write means, if the initial volume in what SI unit they have mentioned, the same SI unit we have to mention here. And the same condition here they have used the pressure. The SI unit as bar. Sometime you may have the atmosphere ATM. So whichever they have given the SI unit, that one you have to mention. So I hope this is very simple concept. So based on the given data, first you have to identify the problem to which law it is applicable, and based on those law we have to rearrange the equation, and substituting that one we can obtain the result. So this is the some important problems. This is first one related to voice. The second one is the problem 5.2. So in the 5.2 they have given that here the ship is going from Pacific Ocean to the Indian Ocean. So Pacific Ocean to the Indian Ocean, where the ship is containing one of the balloon. Here at the Pacific Ocean they have mentioned the temperature. The temperature is 23.4 degrees Celsius. They are having the volume, means balloon. That balloon is filled by the air, that is they are going to have the volume 2 liter. 2 liter is the volume, means the ship is coming from Pacific Ocean to the Indian Ocean. The ocean temperature will be different. So we Indians are having the greater temperature, whereas Pacific they are having the lesser. So Pacific they are having the ocean temperature 23.4 degrees Celsius. At that time the balloon is of the size 2 liter. When it reaches to the Indian Ocean is having the temperature 26.1 degrees Celsius. At that time, what will be the volume of the balloon? This is the question they have asked. Look here, in this question, they have mentioned the temperature in degrees Celsius. First, we have to convert that into the Kelvin. Why? Because the SI unit of the temperature is Kelvin, not degrees Celsius. For that reason, 23.4 degrees Celsius, we have to convert that into the Kelvin. How means we have to add this 23.4 plus 273.5 actually, but we are adding only round figure 273. By adding that 273, we are going to get the degrees Celsius into the Kelvin. So 23.4 plus 273, we are going to get 296.4. So similarly 26.1 plus 273, we are going to get 299.1 Kelvin are getting. So now onwards in the problem, while substituting the T1 and T2, you have to mention this temperature, not the degree Celsius. So here condition they have given initially at a temperature this much 296.4, then the volume is 2 liter. If the temperature is increased to 299.1 Kelvin, then what will be the volume of the balloon? This is the condition. Here we have to think of that it is having the relation between volume and temperature. If the problem is based on volume and temperature, it means it is according to the charge law, because the charge law is going to give the relations between volume and temperature. So according to the charge law, we know that volume is directly proportional to the temperature. As the temperature increases, volume is also decreases. Therefore, by keeping the constant K, we are sending this T to the left side. Therefore, V divided by T. So this is the what we are going to have. V divided by T. It is a constant term. It is a constant term. For that reason, at V1 the temperature will be T1. At the volume V2 the temperature will be T2. Therefore, according to the charge law, V1 by T1 is equal to V2 by T2. Here they have given the T1 V1 and T2 they have given. Here we need to calculate the V2. So V2 is equal to, just you send this T2 to the left hand. So divided it becomes into, therefore V1 into T2 divided by T1 and remaining V2 here only. Therefore V2 is equal to V1 into T2 divided by T1. Are you getting? So just substitute here. V1 is nothing but 2 liter and T2 is nothing but 299.1 Kelvin divided by volume. It's a temperature T1 296.4 Kelvin. By substituting this, we are going to get the volume, that is 2.01 2.0.8 liter. This is the V2. So here it's not necessary to do directly volume only. They may have the tendency to give any of the among this V1 T1 V2 T2. They may give at least any of the three, but they may ask you any of the any one among these four terms. So what you have to remember in this problem is, so whenever they have given the given data, first you have to chart out by given data to which law is applicable here. Based on that, you have to write the equation. Only after writing the equation, you can able to solve this one. So main condition here is you have to recognize the given data, what they have given and what they have asked. Based on the given data, you have to confirm yourself which law is applicable and what will be the formula. This is the important here. Okay, coming to the next one. Next only two problems are there. So these are little bit lengthy, but I don't want to go it very fast. Why? Because these problems are most important and you are not supposed to feel that headache. So try to solve some other different problem whichever I am going to give you as a homework. Write those in a assignment. Okay, so the remaining two problems, they are a little bit different, so we will continue in the next week. Okay, have a nice day. If you are having any doubts, ask me. Okay, bye.